Hello everyone, today we're going to solve set 8, problems 15 and 16. Problem 15. All 4 L shapes shown in the diagram are to be placed in the 4x4 grid so that all 16 cells are covered and there is no overlap. Each piece can be rotated or reflected before being placed and the black dot is visible from both sides. How many of the 16 cells of the grid could contain the black dots? Now, there are 3 possible arrangements of the 4 L shapes. The first possible arrangement is, let me just quickly copy this. Now, the first possible arrangement is this. And if we place a black dot here, and then if we rotate or reflect in any way, these are the possible places for the black dots. For example, if we reflect along the horizontal axis, we have this blue dot here. And the same for example, if we flip vertically along the vertical axis, we have a blue dot here. So if we rotate and reflect, we have 8 possible places for the black dots. Now, the second arrangement is when we have divide this in half and then we cut them like this. Now, the original black dot is up here, and then if we rotate and reflect, there are 4 possible places. Now, for the last arrangement, we can arrange the L shapes by the following, like the following. Now, the original black dot could be here, and then if you rotate and reflect, there can be a total of 4 places of black dots. Now, in total, there are 16 possible places of the black dots. So D is the correct answer. Problem 16. Tim writes down 3 two-digit integers. One is square, one is prime, and one is triangular. He uses the digits 3, 4, 5, 6, 7, and 8 exactly once each. Which prime does he write? Now, for the prime number, let's say, let's think about the last digit of the prime number. 8 cannot work, 5 cannot work, 6 cannot work, and 4 cannot work. So the last digit of a prime number must be either 3 or 7. Those two are the only digits possible. Now, mindful of that, let's look at the cases for other numbers. Let's look at square numbers. For the two-digit square numbers, we have 16, 25, 36, 49, 64, and 81. Now, 16, we cannot make 16. We cannot make 25. We could make 36, possibly. We cannot make 49. We could make 64. And we cannot make 81. Now, we have 2 cases for a square number. Now, let's look at a triangular number. Some of you might not be used to triangular numbers, and triangular number is it just represents the number of dots needed to form a perfect equilateral triangle. So for example, like this, 3 is a triangular number. And then if we have 3 more dots like this, we have an equilateral triangle. So 6 is also a triangle number. And if we have 4 more dots, it's also an equilateral triangle. So 10 could also be a triangular number. Now, this can also be said as the sum of all positive integers until that point. So for example, we have 1, 2, 3, and 4 here. So the fourth triangle number is just sum from 1 to 4. And the sum of numbers until that point is same as n plus 1 over 2. So if we have n as 4, which is the fourth triangular number, we have 4 times 5 over 2, which is 10, which is exactly same to what we've seen here. Now, I'm just going to tell you all the triangle numbers for the 2-digit triangle numbers. We have 10, 15, 21, 28, 36, 45, 55, 66, and 78 and 91. Now, we cannot have 10, we cannot have 15, we cannot have 21, we cannot have 28. We might do 36, and we might do 45. 55 cannot work because each digit should be used exactly once. Same for 66. We could make 78, we cannot do 91. Now there are 3 cases for the triangular number. Now let's just do it case by case. Let's say 36 is the square number. Then we have use 3 and 6 here. Now we have 4, 5, and 7 and 8 left. Now cannot make 36, and then the possible arrangement is either 45 or 78, right? But we need 7 for the prime number, right? We need at least either 3 or 7. So we cannot do 78 because we need that 7 for the prime number. And even though we have a 7, it cannot be a prime number. So for the triangle number, we chose 45, which leaves only 7 and 8 for the prime number. Now, however, 87 is not a prime number because it's a multiple of 3. So 36 cannot be the square number that we chose. So 36 cannot work, which means that 64 is the prime number that we want. Square number that we want. So that means, let me just roll back quickly. That means because we used 6 and 4, we're going to remove 36, we're going to remove 45 because we use 6 and 4, which leaves 78 as the only possible triangular number. That means we have 3 and 5 left, and 53 is a prime number. So these numbers are the correct cases for 1 prime number, 1 triangle number, and 1 square number. So B is the correct answer because 53 is the prime number we chose. Thank you everyone, and I'll see you again. Bye.